This is 1-7, the easy stuff. Solve doing row operations. I'll do the first one because if I don't, somebody will be like, I don't know what to do, Milbrath. Well, you're going to move that 6y over for starters, because when you make a matrix, things have to be in good old STD form, right? So here's our matrix. -1, 2, the bar, which is like semi-optional, and then 1, -6, and 0 for a constant. Now, for a system of two equations or two variables, we need to be thinking about a goal of 1, 0, 0, 1, and some constants. Lots and lots of ways to do this one. I'm going to multiply the first row by a -1. That's going to be my first operation. Row 1 is row 1 times a -1. And that is going to get me a +1 where I need a +1. Now, if you multiply by a negative, you change your signs. Easy peasy stuff. Now, I look over here and I see I need a 0, and I know that 1 minus 1 happens to be 0. So row 2 is row 2, take away row 1 because I was looking at the number above it. That has no effect on row 1. Don't try and do a whole lot at once, by the way. Some kids do, and it really messes them up. 1 minus 1 is 0. Here's where we'd make a lot of mistakes. This is a -6 take away a -2. That becomes addition. -6 plus 2 is -4. And then we have a 0 minus a 2, which is a -2. Not so bad. Alright, what do you want to go after next? Generally speaking, I try to go after the ones first. So I do one column, then I move right. Usually. Sometimes I see things. I saw something on this one I could have done in the beginning, but I decided not to. But I want a 1 here, so I'm just going to divide out that -4. Row 2 is row 2 divided by a -4. Again, that has no effect on row 1. 0 divided by -4 is still 0. -4 divided by a -4 is a 1. -2 divided by a -4 is a 1/2. Alright, now I need a 0 right here. In row 1, column 2, I need that to be a 0. I know that -2 plus 2 ones is a 0, and I know that would not affect this because 1 plus 2 zeros is still 1. So row 1 is row 1 plus 2 of the things in row 2 beneath it. So 1 plus 2 zeros is still 1. -2 plus 2 ones is 0. And 2 plus 2 1/2, 2 times a half is 1. 2 plus 1 is 3. 0, 1, 1/2. And congratulations, you've solved it. What does this say? This says that x is 3, y is a half. And we had one unique, or as the order of pair, by the way, 3, 1. One unique solution. This is called consistent because it has an answer. Consistent means has answers. Independent. Consistent, independent. All right. 1 of 8 problems done. Now let's look at 3 because, 3 is funny. Is 3 in STD form? No, it is not. All right. So let's move all the x's and y's on the left and numbers on the right. So this would look like a 6x plus a twice y. That's odd, it got off like that. Equals 10. This guy would be -18x minus 22y, and it would equal a -14. Now, I'm going to do a couple things on these to make them smaller. Before I ever go to a matrix, like I'm going to use some properties of equality. I'm going to divide this entire row by 2. I'm just going to save it. So I'm going to divide this entire row by 2 and make that 3x plus y equals 5. And I can do the same thing with this one too, I think. I don't see why I couldn't. Make that 9x. I'm going to divide out the negativity, by the way. Divide it by -2. 9x plus 11y equal to 7. So I divided by a -2 and I divided by 2 just to make the numbers smaller. No other reason. It just ought to work better with smaller numbers. I'm going to make sure I don't have any mistakes. Alright, I'm ready for a matrix. 3, 1, 5 is the first row. 9, 11, and what, 7? occur. We might have a problem here. Alright, so usually I do go after the first row. I don't want to, though. It's going to be fractional, which is not what we want to do. So we might save something for the end. We'll see. Let's make this a 0. Remember your goal. Row 2 is row 2 minus 3 row 1s. So no effect on row 1 yet. Let's see here. 9 minus 3 3s is 0. 11 minus 3 1s is 8. 7 minus 3 5s, that's 7 minus 15, that's negative 8. I had a hunch this was going to happen, which is why I did it. Now, like I said, normally I go after this position right here, but I didn't see an easy way to turn that into a 1 other than dividing by 3. So I went after this position, and things worked out. Now, I'm going to go after this guy next. He is supposed to be, well, I'm going to turn him into a 1. It was 1 0 0 1, which is the way it's supposed to be. So row 2 is row 2 divided by 8. Zero divided by 8 is still 0. 8 divided by 8 is 1. Negative 8 divided by negative 8 is negative 1. So why did I do all that stuff? Well, because I saw that ahead of time. I was thinking about a desired outcome. Next move, I'm going to go after this 1 right here. Row 1 is row 1, and if I do 1 take away 1, I have my desired 0. So row 1 is row 1, take away row 2. 3 minus 0 is still 3. 1 minus 1 is 0. 5 minus a negative 1 is 6. That was 5, take away a negative 1. That's something that's going to get a lot of kids. And now I can see that I can divide this 3 out nicely. If I would have tried to fix this 3 up here, I would have introduced fractions. If I was a computer, I'd have been fine with it. When I wrote code for this in computer science, that's how we did it, because it was the easiest thing to do on code-wise. But now row 1 is simply row 1 divided by the 3. 1, 0, 2, 0, 1, negative 1. So what did we just learn? We learned that x is 2. We learned that y is negative 1. If we like ordered pairs, it's 2, negative 1. And this has one unique solution, so it is consistent and independent. Consistent and independent. 7 will be the next one I do, and probably the last one I do. That's 3/8 of your homework. In class, we'll probably do 2 more. That's 5/8. Maybe you'll get something else done. I don't know. So I'm also going to do some funny things here. Like I'm going to double this equation, and I'm going to multiply this one by a negative 4. Just because that way when I look at my matrices, I see better numbers. That'd be an x plus 8y equals 20. So again, I'm just trying to clear the fractions. It just makes it easier, better to look at. X plus 2y equals 8. X plus 8y equals 20. Good with that. 1, 2, 8. 1, 8, 20. I think I'll attack that first, because remember your goal is 1, 0, 0, 1, some constants. So row 2 is going to be row 2 take away row 1, because 1 minus 1 is nothing. I already have a 1 here like I want. So 1 take away 1 is 0. 8 take away 2 is negative 6. 20 take away 8 is 12. 2 moves and this one's done. That right there, that's supposed to be a 1. Row 2 is row 2 divided by negative 6. 0 divided by negative 6 is still 0. Negative 6 divided by negative 6 is 1. 12 divided by negative 6 is 2. Negative 2 at that. And the last one is to put a 0 right here. And I know that 2 take away 2 1s is nothing. So that is my row operation. Row 1 is row 1. Take away twice row 2. 1 take away 2 zeros is still 1. 2 take away 2 ones is 0. 8 take away 2 negative 2's is 12. That was 8 take away 2 negative 2's. Negative times negative is a positive. 8 plus 4 is 12. 0, 1, negative 2. Alright, so we have a unique solution. It's 12, negative 12. X is 12, y is negative 12. And since it has one unique solution, it is consistent and independent. There you go, kids. There's 3 of your 8 homework problems done. And I'm assuming you'll probably ask for some more tomorrow because it's reduced row echelon form, and nobody likes reduced row echelon form.